I hope you understood the previous class. If you didn't watch the previous class, I'll just keep the card right here. You can watch the class and come here so that it will be easy to understand this class. And I gave a small sum to find Hcf of two numbers, LCM and Hcf of two numbers. And let's see how to find the LCM and Hcf. So, in chapter 1, real numbers. And the two numbers I gave to find the LCM and Hcf are 84 and 90. So what should we do before finding the LCM and HCF? We should prime factorize them. So how to prime factorize? 84. What is the first prime number? 2. So 84 divided by 2 is 42. And is 42 divisible by 2? Yes. So what is 42 by 2? It is 21. Is 21 divisible by 2? As it is not ending with an even number, it is not. What is the next prime number? 3. 21 is actually divisible by 3. So 3 sevens are is 21. So let's write prime factorization of 90 now. 90. It is ending with an even number, so it is divisible by 2. So 90 by 2 is actually 45. 45 is not ending with an even number, so it is not divisible by 2. So what's the next prime number? 3. Is 45 divisible by 3? Yes. 3 15s are 45. And again, is 15 divisible by 3? Yes. 3 5s are 15. How do we write them? So there are two 2's here, so it is 2 square into 3 into 7. Next 90. There is only one 2 is 2 into 3 square into 5. So how to find the LCM? What are all the numbers which we can find in this box? I mean in this prime factors. We can find 2, 3, 5 and 7. What is the highest power of 2 here? We can see the highest power of 2 is 2 square. Not so 2 power 2 is greater than 2 power 1. So 2 square. How many 3's we have here? So 1 3 here and other one here. What is the highest power of 3? 2. And we have only one 5 and the power of 5 is 1. Next we have only one 7 and the power of 7 is 1. So the LCM of the two numbers 84 and 90 is equal to multiplication of the four numbers 2 square into 3 square into 5 into 7. 5 power 1 is 5 and 7 power 1 is 7. So 4 square 4 sorry 2 square 2 into 2 it is 4. 3 square 3 into 3 it is 9 into 5 into 7. So what is 5 into 7? It's 35. Now let's multiply 4 and 35. 35 into 4. So 4 5s are 20, 3 4s are 12 plus 2 is 14. So it will be 140 into 9. 140 into 9. So let's take this out. Okay. 9 zeros are 0. 9 fours are 36. And 9 ones are 9 plus 3 is 12. It is 1260. So the LCM of 84 and 90 is 1260. Next, HCF. HCF of 84 and 90. Again, write the prime factorization expanded in the expanded form. So it will be, sorry, not this. Oh, yes, this both in expanded form. So 2 square is 2 into 2 and 3 into 7. And what's the next one? 2, 3 square and 5. 2 into 3 into 3 into 5. Don't kill this is equal to. So again. Next, what are the common what what are the common things you can see in both of them? We can see that one set of 2 is common and one set of 3 is common. So the HCF of 84 and 90 will be equal to 2 into 3 because 1 2 from here and 1 3 from here. So 2 3s are 6. Hcf of 84 and 90 is 6. Let's see another two numbers. So I hope you got the same answers as this. Let's see 24 and 15. Let's prime factorize. 24, is it divisible by 2? Yes. 2 12s are 24. Is 12 divisible by 2? Yes. 2 6 are 12. Is 6 divisible by 2? Yes. 2 3s are 6 and 3 is the prime number itself. So 15. Is 15 divisible by 2? No. But what's the next prime number? 3. Is 15 divisible by 3? Yes. 3 5s are 15 and 5 is the prime number itself. So what it will be? 24 is equal to 2 into 2 into 2 into 3. 15 is equal to 3 into 5. So now let's find the LCM first and use the relationship of LCM and HCF which I explained in the previous video to find the HCF. Okay. So LCM of 24 and 15. What are all the numbers we can see in this both? Again, I can see 2, I can see 3 and I can see 5. So where are the 2's? Here. How many 2's are there? Only 3 2's. So it will be 2 cube. Next, how many 3's you can see? Here only 1 3 here and 1 3 here. So only 1. Only 1 5 is there, so 5 per 1. So I hope you understood. Let me say it again. So, sorry, 1 minute. 24 is equal to 2 cube into 3. 15 is equal to 3 into 5. Highest power of 2 is 3. There is only 1 2 and power of it is 3. We can see two 3's here. One is here, one is here. And highest power of 3 in both of the 3's is only 1. So 1 and 5 power 1 is only 5. So LCM of 24 and 15 is equal to multiplication of these three numbers. So 2 cube into 3 into 5. What is 2 cube? 2 cube is 8. 3 5s are 15. Next, 15 into 8. 8 5s are 40. 8 1s are 8. Plus 4 is 12. It will be 120. So LCM of 24 and 15 is 120. Next, let's find the HCF using relationship between LCM and HCF. So what is relationship? LCM of A and B into HCF of A and B is equal to A into B. So what will HCF of A and B will become? HCF, what are A and B here? 24 and 15 is equal to 24 into 15 by LCM of 24 and 15. So HCF of 24 and 15 will be 24 into 15 by 120 because LCM of 24 and 15 is 120. Let's simplify it. So 5 3s are 5 2 4, 24s are. Next 24 and 24 cancel. So HCF of 24 and 15 is 3. Now let us check an interesting question. So the question is, so the question is explain why 7 into 11 into 13 plus 13 is a composite number. So before solving this question, we need to understand one theorem. We have seen in the first lecture, it is fundamental theorem of arithmetic. What is the theorem? Fundamental theorem of arithmetic. What is this theorem? It normally says that every composite number can be expressed as a product of prime numbers. Every composite number can be expressed as expressed in the form of prime numbers. So in this sum we expressed 84 as 2 into 2 into 3 into 7. So we just read that every composite number can be expressed as a product of prime. So as 84 is expressed as product of primes like 2, 3, 7 are prime numbers. So 84 is a composite number. So that is fundamental theorem of arithmetic. It is just composite number which can be expressed in the form of prime numbers. So now the question is we should prove that 7 into 11 into 13 plus 13 is a composite number without adding or multiplying. So 7 into 11 into 13 plus 13. In this you can see that 13 are common. So let us take 13 common in these two terms. So 13 into 7 into 11 into 1 plus 1. So 7 into 11 into 1 is 1, so plus 1. So 7 into 11 is 77 and 77 plus 1 is 78. So now 13 is a prime number, so let us leave it like that. Let's write 78 as product of primes. So 2's are as 8, 78 is an even number. 2 3's are 2 9's are. Next 39, it will not go in 2 table, so 3 table. Yes, 3 1's are, 3 3's are, and 13 is a prime number itself. So 13 into 2 into 3 into 13, which can be also written as 13 into 13 into 3 into 2. So 13, 3 and 2, 3 are prime numbers. So according to fundamental theorem of arithmetic, let us write, I'm going to write it in short form. So fundamental theorem of arithmetic, 7 into 11 into 13 plus 13 is a composite number. Right? So let us see another sum in this same manner. Now example is, explain why 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. So we should show this whole number as product of prime numbers. So here we have 5. Do we have 5 here? Yes, we do have 5 here. So let us take 5 common in these two terms because 5 is common. So it will become, sorry, it will become 5, 7 into 6 into 1 into 4 into 3 into 2 into 1 plus 1. This is 5 into 5 and plus 5. It will become into 1 and plus 1 because I have 5 common here. So according to Bodmer's rule, we should solve the brackets, the terms in the brackets first. So 7 6 are 42, 4 3s are 12, 12 twos are 24, into 1 is the same thing, and plus 1. So what is 42 into 24? 42 is into 24 is 1008. What it is? 1008, and of course plus 1. So it will become 5 into 1009. We don't know the prime numbers exceeding 100, but 1009 is indeed a prime number. So again, by fundamental theorem of arithmetic, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 1 is a composite number, right? So next example. This is a little bit tricky sum. So it is 7 into 11 into 2 plus, sorry, it is not 7, it is 17. 17 into 11 into 5. We should explain the same thing. Explain why it is a composite number. So in this we can see that both 17 and 11 are common. So let's take them common. 17 into 11 in 17 into 11 in brackets 2 plus 5. What is 2 plus 5? 2 plus 5 is 7. So 17, 11, 7 are prime numbers. See, 2, 3, 5, 7. 11, 13, 17, 19. So these three are prime numbers. So again, by fundamental theorem of arithmetic, 17 into 11 into 2 plus 17 into 11 into 5 is a composite number. Okay, let us see another sum. So this sum is, explain why 7 into 5 into 3 into 2 into 1 plus 3 is a composite number. So these are the two terms. What is the number which is common in these both terms? 3 is common. So 3 common, 7 into 5 into 1 into 2 into 1 plus 1. So again 3 into 7 5 is so what is 7 5 is 7 into 5 is 35. 35 into 2 plus 1. So 3 into 35 into 2. 35 into 2 is actually 70. So 70 plus 1, it is gonna be 71. So 3 into 71. And again, 71 is a prime number. So we'll write the therefore statement again as 7 into 5 into 3 into 2 into 1 plus 3 is a composite number by fundamental theorem of arithmetic. So you can do this sum. Let us see. Example. Explain why. So they're indirectly saying that it is a composite number, but they're telling to explain why it is a composite number. Explain why 17 into 11 into 7 into 5 plus 11 into 5 into 3 is a composite number. It is a very simple sum, you can do it. I know that. I hope you understood today's class. Just do the extra sum I have given. I will give the solution of it in the next class. Subscribe so that you don't miss the answer of it. And signing off, Gyan Sagar. And thank you.